Well, now we're doing worksheet 11C, so I hope you have that out, and we'll march through these questions. And if you think I'm going a little fast, keep in mind you can always, back up and redo a question. So, first one, what is one way to decide if two numbers follow a Fibonacci sequence? Well, the answer is B, if their ratio is approximately the same as the golden ratio. And let me show you what the Fibonacci sequence is. Starts off with 1, and you add that and the previous number to 1, which happens to be 0, and so 1 plus 0 is 1. Then you add these two numbers together, and you get 2. Then you add these two numbers together, and you get 3. Then adding these two together, you get 5. Then adding these two together, you get 8. And adding 5 and 8 together, you get 13. And so on. Continues like that. You add the number and the previous number, and that's your new number. So now, notice 5 and 8 is the golden ratio, and their sum is 13. So that's the Fibonacci sequence. Now let's do number 2. And a line subdivided according to the golden ratio with the smaller piece having a length of 2 meters. What is the length of the entire line? So we know this, that 8 over 5 is approximately the golden ratio. And that equals, the shorter values 2. By the way, the total length, if we were to add these up, would be 13. 5 and 8 is 13. So now, 2 and x, and this ratio has to satisfy this ratio, the smaller length of the golden ratio dividing the sum of 8 and 5. So now to isolate x, we just multiply both sides by 2. These divide out, so x equals 26 over 5, which equals 5.2. And you can see it is A. So number 3, given 2.6 inches is one side of a golden rectangle, find the length of the other side. Notice that the other side could be longer or shorter than the given side. So here's what we'll do. An approximation of the golden ratio is 1.62, which is approximately 8 over 5. The actual golden ratio I'll get to in a moment. In fact, you can look it up in the book, and that is on page 615. Page 615, that's where you'll see it. So what you do, we're given the number 2.6, so to find the length of the other side, we're going to multiply by 1.62, and that gives us, I think, 421. 4.21. On the other hand, what if 2.6 is the longer side? How do we find the shorter side? Well, we're going to divide 2.6 by 1.62, and now we'll get 1.60 approximately. So those are the two candidates, and you'll notice that that corresponds to the selection C under 3. So let's look at, I think we're going to do the same thing for 4. And let's see, 4 says, given 0.14 centimeters is one side of the golden, that's one side of the golden rectangle. Find the length of the other side. Notice that it could be longer or shorter. So we're going to multiply 0.14 times 1.62, and we're going to divide 0.14 by 1.62, and those will give us our other two options. And when we do that, we get 0.23 or 0.09 when we round. And so I think that option is B. B. And by the way, this is 4. So now, let's actually look at what the golden ratio is. And it is, they call it phi equals, and it's 1 plus the square root of 5 divided by 2. Well, this is an irrational number. If you put in your calculator, it'll take it out to about 7 digits, but it goes on forever, never repeats. So now we're ready to do, and notice we approximate that by saying it's 1.62, or, which is approximately 8/5, which is a nice easy way to recall. So number 5, provide an appropriate response. The golden ratio is, and it is an irrational number, D. So now, the golden ratio was used in, and it was used in Greek architecture. That ratio, if you have a rectangle that conforms to that ratio, the ratio of the two sides is about 8:5, then it's very pleasing to the eye. Now, what fraction is approximately equal to the golden ratio? Well, it's going to be A, this is number 7, 8/5. And finally, divide the line below into two sections that satisfy the golden ratio. And by the way, I've done that on the other video in this section. So look that up, please. Anyhow, got her done.